So now I want to introduce you the support vector machine algorithm. Support vector machine algorithm is one of the most popular supervised learning algorithm, which is used for classification, but also for regression problems. However, this is mostly used for classification. The goal of SVM algorithm is to create the baseline or decision boundary that can segregate n-dimensional space into classes so that we can easily put the new data point in the correct categories in the future. This best decision boundary is also called a hyperplane. SVM chooses the extreme point that helps in creating the hyperplane. These extreme cases are called support vectors. For example, in this graph is this one. And if we see, so if we see it from this graph, we can see these are the hyperplane, and this is the support vector. SVM can use different kernels to draw different decision boundaries. So transform the data and then draw a linear boundary and transform the space like this one, from this one to this one. It prevents overfitting. And there are two types of SVM. So the linear SVM is used for linear separable data, which means if a data set can be classified into two classes by using a single straight line, then such data is called a linear separable data, and we'll use a linear SVM. And if the data is not able to be separated in using a straight line, then we call it a nonlinear separable data, and the classifier is going to call it a nonlinear SVM classifier. So for example, we have this data sets, and we see that if we get, for example, if we give them like two lines here, both of these lines are able to separate the data into two classes. However, if we calculate if we calculate the margin between the vectors, the support vectors, which is this one and this one for the right line, and we'll see this margin is right here, so it's not like very long. But for this green line, the margin will be this one, and we'll get a much larger margin. So for the SVM algorithms, we need to find a line that gives us the largest. We want to maximize this margin, so we can better separate these two classes. Yeah, and the margin is calculated as the distance between the support vectors. And if a data is non-linear data, we cannot draw a single straight line. So we consider about like this image. So now we need to transform this a little bit. We let z equals to x squared plus y squared. And then we replot this data. Now we are able to see how we're able to use a linear plane to separate them. And since we are in a 3D space, it's looking like a plane parallel to the x-axis. So if we convert it into 2D with z equal to 1, then we got something like this. So we're basically before we're using we from this one to this one, we're actually is managing to make this data from 2D to 3D. And now if we get it back to 3D, this hyperplane is going to look like a circle on the x and y axis. Yeah, So like for example, if we have some data like this, and if we use a linear kernel, it's going to separate the data like this one, where this is classified as type 2 and this is classified type 1. But actually, this is not what we expected to separate them, because we know these are type 2, then this is type 1, and we're going to get a big, very small accuracy and a large error on this one. Whereas if we use the radial kernel, we're able to very well like get 100% good separation on this one. Yeah, so it's really important to know your data feature before you choose the kernels for SVM.